Good evening and welcome to the PWI Technical Meeting for November. My name is Prath Nanthakumaran and I'll be chairing the session today. I would like to acknowledge the traditional custodians of the land on which we meet today and pay my respects to the elders past and present. I extend my respect to the Aboriginal or Torres Strait Islander people who are present today. Today also marks Remembrance Day, and we honour the Australian servicemen and servicewomen who have served our country. A snapshot of the agenda is on your screen. And for the viewers here at the venue, a quick safety briefing. If you hear a whoop whoop sound, we'll have the fire wardens escort us out back onto Goulburn Street, the way we came in, and we'll meet at the assembly emergency point at Hyde Park. So out back onto Goulburn Street, left onto Castlereagh, and then right onto Liverpool Street. So thanks to the subcommittee, the technical subcommittee, including Ray Slaviero and Elaine Human, who put this event on tonight. And Mark Harris sends his apologies. So for the viewers at home, if you're a new member, please enter your name in the comment box and we'll make a note of that. I'm not sure if there's any new members at the audience here today. It seems not. Okay, AGM wrap up. So despite another COVID-19 challenging year, 2021 has been overall a successful year for PWI New South Wales. And that's because we can do live streaming. And also our dedicated members and our trusted corporate sponsors. Our achievements this year include establishment of the Don Haggerty Cadet Program, setting up the PWI Electrical Subcommittee, PWI working with the ARA to present a session at Ausrail in Brisbane in late November, 3 Young Achiever Awards, and continued and well-attended technical meetings, which we've also streamed online. The Treasurer's report showed a loss of $13,343, which was expected due to the various event cancellations, such as the executive breakfast and reduced in-person attendance. Our assets and liabilities are healthy, with a total members fund of $454,000 as of the end of 30th of June. The financial report was audited post-AGM and signed off by the committee. Committee nominations and elections included majority of current committee members, with David Foldi as returning officer. The office bearers were re-elected unopposed, with Ben Crooks taking on the Treasurer's role. Additional authorised officers include Dan Collison and Mark Butler. A wrap-up of our last technical meeting in August. It was sponsored by CIMIC Mining, and it was a very insightful meeting. Kevin Gollidge and Ross Barber gave an overview on how mining subsidence is being effectively managed at Tarmore Coal Mine, regional New South Wales, operating under an active railway with emphasis on processes for approval and the teams involved in planning for rail subsidence, pre-mining infrastructure prep, and monitoring and managing the infrastructure during mining. The PWI annual convention was held on the 29th of October, and it was a hit. The keynote speaker was Matthew Longland, the CEO of Sydney Trains. Matthew addressed how Sydney Trains managed their complex operations through the challenges of COVID-19 and outlined Sydney Trains' future priorities, including the focus on customer, integrated service planning and growth, and technology-enabled operations. Rail is truly a great road to recovery. The speakers looked at how existing and future infrastructure projects can play a pivotal role in our economic recovery across New South Wales and the importance of innovation, technology and sustainability in the process. Peter Colacina, as one of the leading voices in Australian infrastructure, Mark Harris had a one-on-one conversation with Peter on Infrastructure Australia's vision and roadmap for infrastructure reform, with the current focus on sustainability, resilience, placemaking, industry productivity and innovation. The panel explored the role of rail infrastructure in the post-COVID-19 economic recovery. The future is bright for rail and we all have a role to play. So PWI is looking to diversify, and in doing that, we are excited to announce the formation of the Overhead Wiring and Electrical Subcommittee. So if you want to get involved in our Overhead Wiring and Electrical Subcommittee, feel free to reach out to Michael Cox at middletongroup.com.au. So now that COVID-19 is somewhat behind us, we're looking to open things up and hold our events as per normal. So next year is going to be fully packed with our usual events. We'll have the PWI Awards, the Golf Day, the Executive Breakfast, the Winter Dinner, and the annual convention. Please lock in the dates and save it in your calendars. Early next year, on the 11th of Feb, we'll be holding our PWI Awards night. This will be held at the Ivy Ballroom, the same as last year. Last year was a hit, and I'm sure, well, this year was a hit, so I'm sure next year will be the same. In March, we'll have the PWI Golf Day, so make sure you register and sponsor a hole if you can. In June, we'll have our annual Winter Dinner. And then in May, we'll have the Executive Breakfast. A current snapshot of our membership. Corporate members, we have a total of 50. Enhanced corporate members, we've got 1 silver available. Personal members, we have 106 currently financial, and we're looking to get more. So please get in touch with Steve Namoski, who's our membership secretary, if you want to join or your company wants to join. Next year's technical meetings. In February, we have a sponsor lined up, and that'll be JMDR. We also have June locked in with WSP, who usually hold the June technical meeting combined with the IRSE. So please get in touch with myself or one of the technical subcommittees if you'd like to book in a spot. Thanks to our enhanced members. Okay, that brings me now to the technical meeting. So thank you to ArchArtifex, who have sponsored tonight's or this evening's event. And the speakers today include David Jones. David is a director at Project Services Group with ArchArtifex. David has 18 years experience in engineering management and leadership roles on transport infrastructure, wastewater and power projects. Andy Petrie is the Director, Systems Engineering and Safety Assurance with ArchArtifex. Andy has 25 years experience in Australia and the UK, having undertaken key roles with TfNSW, Network Rail and Transport for London. Jonathan Louis is Director, Systems Engineering and Systems Safety Assurance with ArchArtifex. Jonathan has 20 years experience in the transport sector, working with TfNSW and London Underground in engineering and project management roles. So I ask the viewers at home, if you have questions throughout the presentations, please ask your questions on the comment box on the right-hand side of your Teams program. So I'll welcome David first to the stage to kick off the presentation. Okay, so you'll have to just click it. Okay, sorry.
Hello, welcome. That's what we've got. Good. Okay, so I'm David Jones from ArchArtifex. We're going to run through systems engineering, safety assurance, a briefing on that. I'll run through what I've got. So you said agenda that we'll run through. So I'll do a sort of brief round of introductions on who Arch are and the speakers as well. And then Andy will run us through some system safety content, which will be really sort of hone in on what we look for in Permanent Way and Permanent Way Institute. And Jonathan did the same for systems engineering. And also like to recognise and acknowledge the team at ArchArtifex, acknowledge the Gadigal people of the Eora Nation and those on whose land that we meet on today. So Arch was founded in 2014 by John, who's sitting in the stand here today, sitting in the room as well. It was John's vision was to create an alternative consultancy model focused first and foremost on delivering measurable outcomes for our clients. From those initial engineering and project management services, Arch quickly expanded into systems engineering and safety assurance, and leveraging our deep knowledge of how projects are delivered on site and to provide Cisa team that drives value. In 2018, Arch welcomed Artifex into the business, and as part of the team's commitment to provide clients with a wider range of services. Artifex was founded in 2005 and increased our breadth of project services division, which I'm now part of. And also brought one of our directors, Steve Namolsky, who you heard Praf mention before. Our core focus it's delivering real value. We've been contractors, consultants, clients, and we can really find that we add a whole lot of value, and we're stronger together by having that project lifecycle experience within the business. If I skipped on a bit far, sorry. No, okay, that's good. So there's two parts of the business. There's the project services group and the Cisa group. So the project services group, we've got engineering and project management, constructability, interface management, project controls, communications, stakeholder engagement, and independent ISCA rating assessment as well. That part of the project services that we deliver. And the systems engineering and safety assurance group, who you're going to be hearing from Andy and from Jonathan today. The safety assurance, systems engineering, requirements management, RAM analysis, AO authorization accreditations, where I'm still getting fairly involved. ISA, so independent safety assessment, and human factors as well. Where we work is it's New South Wales based, but providing services Queensland, Vic, and WA as well. It's a real sort of seeing a lot of growth opportunities in those other areas, and it's something we're certainly looking at really closely at the moment too. In general, 150 projects delivered across Sydney, so New South Wales, 160,000 requirements managed, and not all of them on Sydney Metro. And 2,500 safety hazards controlled as well. So that's a bit on Arch. First up is Andy, who's going to run through system safety and safety assurance.
We did make David promise not to wear a suit, but unfortunately he has gone and got changed, so he's showed us up a little bit, but hopefully it's... So what is system safety and safety assurance? This is a question that I explain a lot over my career and have spent a lot of time over the last few years talking to people about. First of all, it's not work health and safety. That is 101 when we have these conversations. It's not about PPE, it's not about worksite briefings, it's not about those normal controls. What it is, it's an engineering control that works in design, planning and building complex infrastructure, complex systems. It does have a role in business as usual, operation and maintenance, but I'm going to focus very much on the change side today. It started probably in the 1960s, 1970s in the UK in its current form with ICI. A couple of gentlemen called Trevor Kletz and Frank Lawley came up with the 6-stage hazard process. Probably about the same time in America, Dow Jones, I can't remember the name of them, were actually coming with the similar sort of things as well. Those processes became embedded and were moved into other industries as well. So the nuclear industry, for one, also adopted a lot of these processes. A lot of you will know in the UK in the late 80s and the 90s, there was a lot of very serious rail accidents, Clapham Junction, Hadfield, Ladbroke Grove, etc., where there was some significant amount of fatalities. At the time in the UK, there was the same safety regulator covered all industries, and they basically said you need to start using the processes they've developed in the high hazard chemical and nuclear industries and bring them into the rail. And some of you will know the Yellow Book and now the IESM standard that's following on from that. This actually follows my journey as well. So I started in chemical engineering. My first job at university was doing hazard studies on oil refineries and spent several years going around ICI plants, doing risk assessments. And then as the industry shifted and the chemical industry dropped off in the UK, a lot of people moved from chemicals into rail. My first rail job was really working on the Class 390 Pendolino with Alstom and starting to do some change management and system safety with that. This does also explain why most of the more mature safety professionals that you have are Northern British men, because they all worked in the chemical and nuclear industry back in the 1980s and 1990s. And then obviously with the waterfall incidents and the similar things that happened in Australia, a lot of those people moved over here. Rob and the team will know that a few of the people at Railcorp and Sydney Trains and set up the whole industry around that. So again, trying to explain what system safety is. It's not work health and safety, I said that, but I'll just give you an example. This is what's known as the hierarchy of control. So when you identify a hazard or a safety risk, you start at the top, you try and eliminate it, and right at the bottom is PPE, where you've not been able to do anything about it. System safety really looks at those top parts of it, where we're looking at planning, the engineering process, and the human factors. It does get a little bit blurry at the bottom where there's that administrative controls, and particularly when you're looking around a construction site, the lines can get a bit blurred. But if you focus on the system safety is looking at the product and how it's used afterwards, and the construction health and safety is how you're building it. Safety and design chair, there's a few things where they overlap slightly, and it does cause a bit of confusion sometimes where we're actually doing it. So being really clear where the boundaries are, or at least appreciating that there is a boundary, and having a discussion between the two can pay huge dividends. So when I talk about a system, what do I mean? I'm going to take a theoretical project here, which is a junction remodeling at the end of a station. Now, everyone in the room has probably worked on a similar project. You have to move the track, you have to move the junction work, you have to update the signalling, move the overhead wires. You have to consider the person in that. So you have your signal siting committee, your maintainer, your operators, etc. What system safety is doing is actually saying let's look at those component parts and identify the interfaces between them. So we know a track designer can design track. That's not an issue for any of us. We know a signal designer can design signaling. But what we actually want to make sure is that the two of them are talking together and making sure that if one of them is moving a block joint, it's not affecting the track circuit such that the signaling's screwed up. So it's about identifying the issues and the interfaces. Then you have outside of the project as well, because the railway is a massive, massive system in its own right. There's a whole heap of things on there. I'm not going to go through them all. You can all read them straight away. One of the examples we had a few years ago on a railway not too far away from here was when a crossing was replaced, and they replaced a high-speed crossover with a slow-speed crossover. Simple piece of kit, they had one in the store, brought it in and brought it into use. What that did do was it put a speed limit on the crossover, That meant the trains couldn't meet the timetable, meant the timetable was running late constantly, and the drivers were then running against red lights, and they had to tweak the timetable just as it was going live to actually make it happen. So it's understanding that the smallest impact that everyone thinks is okay can actually affect the railway as a whole, and understanding the impact that asset changes can have on services. So system safety, what it's about, it's identifying those interfaces and making sure that they are being managed and considered. Safety assurance, it's the same part of the same process, but it's a different activity. Now, safety assurance causes a whole heap of pain for a lot of people. If you type assurance into Google, it comes up with a noun, a positive declaration intended to give confidence. And that's what I put in all of my presentations when I'm talking about assurance. So one party saying to another party, I have done a good job here, it is fine, trust me. And the other party has to then do some checks and balances to accept that assurance back. It's about confidence, it's about trust. It's about making sure that if there's a low risk, you accept the word of the track designer that the track designer's done the job. If you're introducing a new system like digital systems, which has never been done in Australia, you've never overlaid ETCS level 2 on traditional signalling, there's a whole heap of risk and issues there. So you have to stick your nose in and actually have a proper prod around, because you don't just take their word for it. The other part of assurance is that assurance is primarily done by the designers and the engineers. I've worked in system safety for 20 years. I cannot do safety of track, I cannot do safety of signalling, I cannot do safety of overhead wires. That's the job of the designers and the engineers to do that. What they then do is they provide an assurance statement that they've done their job properly. It's then the role of the system safety people to pull all those pieces together, make sure that all of those items that we looked at the start have been covered, and then if we're happy, provide an assurance report, an assurance case over the top of that that says the system is safe and I'm confident. The risks have been managed, the due diligence checks are there, and safety has been managed so far as is reasonably practical, as so far that term we all know. So that's the safety case at the end of it. One of the things that you'll find is that when I say safety case, someone will say safety assurance report, someone will say safety assurance statement, someone will say safety assurance risk statement, someone will say safety assurance case report. It's all the same document. Scalable and proportionate is the same thing. It's about giving an explanation of what you've done and why. Trying to explain the process very quickly. I was thinking the other day that the basis of a management system, everyone agrees now, is plan, do, check, act. Everyone's happy with that. System safety is part of the planning process. It's where you go through what you're intending to do, what changes you're intending to make, managing those interfaces, planning what you're going to do, identifying the hazards. Then somebody does the safety. And again, as I said, that's the track engineer, the signal engineer, the overhead wire engineer, the human factors professional. As a system safety professional, I don't do the safety. I just look over it. The safety assurance is the check. You bring it together, you do the safety assurance report, you collect the outcomes, you hopefully can provide a report that says it's a FARP. You hand that over to the governance body and they act by saying, yes, that's fine, we'll accept it, or saying that's wrong, go back to the drawing board. So in simple terms, system safety is the plan and the check. The do is up to the engineers in the room, and the governance is the act as to whether they accept it or not. So those simple steps around there. The key to it is the hazard log. Every system safety process needs the hazard log, which is a register of those decisions and those choices that you make throughout the process. Now, as system safety professionals, we love an acronym, and I'm not going to go through all of these, but you'll have come across and heard many of these along the way. Quantified safety risk assessment. If you do a proper risk assessment at the planning stage, you can actually justify not doing a whole heap of work that the standards may require. It's really well established in other parts of the world, but not something that really is bedded down, hopefully, here in Australia quite yet. Human factors, really, really important. When we look at a system, we always generally focus on the asset and the physical stuff because that's what we do, we're engineers. But the other half of the system is the people operating it, the people maintaining it, and the people using it. And you have to bring them together to consider the system as a whole. We can talk about any of these later. If anyone has any questions about acronyms, you can always drop me a line and we'll try and explain what they are. And then finally, we did say the do's and the don'ts. This is what makes system safety work well, is planning what you want to do at the front and sticking to what you said you were going to do. Don't make things up on the fly. Don't try and change things halfway through. If you've ever been questioned about why you've done something or why you haven't done something, The best answer is we did what we said we were going to do in the plan. Thanks. I appreciate you have a different view, but we've delivered the plan. So plan what you're going to do and stick to it. Scale your approach. One of the things that I was talking to the team the other day, back in the UK, I worked on the East London Line project, with 7 kilometres of new railway, 4 new stations, new signalling, new overhead wires, linking into the mainline network. The safety case that we had for that was 20 pages long. We've got safety cases for lifts and escalators in Sydney Metro that are 5 times the size of that. The hazard logs for weekend possessions I've seen are bigger than the entire hazard log for that East London Line project. Scale what you're doing, make sure you've got the right thing and it's efficient and you're not overdoing it. The taking the one size fit all and applying it to everything, it does work, but it's very expensive and causes you a whole heap of delay and extra resources. Focus on the outcomes, what you're trying to achieve. You're trying to achieve something that's safe, reliable, fit for purpose, maintainable, operable. Don't start going through other people's work and picking up quality mistakes. That's not your job when you're doing safety assurance. The job is to be confident that they've done the right thing and it's good enough. Accept positive assurance, as I said, it's the role of one person gives assurance, the other person accepts it. If somebody comes to you and says, I have done the right thing, I'm sure I have, you should take them on. Some people will say, I don't believe you. Show me the evidence and start going through piles and piles of paperwork from years ago. It doesn't add any value whatsoever. It just brings delays and problems into a project. This is one of my mantras, good enough is good enough. You don't get any points to going beyond what you need to do. Some organizations will gold plate safety. They will, where a 20-page report will do, you'll get a 50, 60, 70-page report. Work out what you need to do and just do the bare minimum to get to that place. It's good enough is good enough. That's where the value is. Ask for guidance. As I say, a lot of organizations will bring the work health and safety professionals in to do the system safety. They soon find after a very short period of time that they then need to go and bring someone else in to actually help them fix that. So work out what you're doing, get the right guidance at the front, and it will help you do that planning. Build confidence that's justified. Don't just take people's word for it because they're your mate. Take their word for it because you've had a look at the documents and done some risk-based checks. Don't start on the basis that you don't trust anyone, because all you're going to do is cause pain for the project in your own life. And again, what the safety assurance process is it ensures that safety is managed and has been managed properly. Your job is not to manage safety. My job is not to go and tell the track designer how to design a track safely. That my job is to check that they have done it, they're competent and they've followed their own processes. And again, another one of my favorites, keep it simple, stupid. It's one of those phrases that goes around. You can keep this a lot simpler than most organizations are doing it right now. And again, that's the mission I'm on, is to try and keep these things as simple as possible. That's all on my system safety, systems assurance. Jonathan is now going to come up and talk about systems engineering.
Okay, so thanks for having me. I'm going to talk through systems engineering, but it's a big topic, so in 15 minutes I'm not going to cover everything, so it's a bit of a grab bag. But I will start with the definition of a system. So a system is a combination of elements that together, organized in a certain way, provide a function. So yes, a bridge is also a system. So don't be confused when systems engineers start talking about systems. I don't think that's about radio systems or electrical systems. A bridge in this world is also a system. And so systems engineering is the interdisciplinary approach of managing the technical requirements and so on to meet the stakeholder expectations and needs of the client. So systems engineering is scalable. So you want to scale the processes that you apply to the complexity, risk, and novelty of the project. So, for instance, that's delivery of a complex metro system is not the same as delivering a said bridge. It does have its roots in the defense industry. So where they talk about things like capabilities, right? So we want to have this capability, and then the systems engineer's job is to break that down, understand what component subsystems are required to deliver that capability, and then rebuild that back up to actually provide that capability. In a lot of the rail applications that we have, a lot of the systems are well-defined products. coming together. So there's less of an emphasis on that, really fundamental defense industry style systems engineering, and ultimately systems engineering is, from a lot of people's point of view, is just good engineering management, making sure that you design and deliver the system that you expect to and wind up with it at the end. So here's a bit of a quote that I like. So a system is not the sum of its parts, it's a product of their interactions. And that's really what systems engineering is about. It's making sure that the person that's designing the track and the person that's designing the signaling and the rolling stock, and it all fits together and interacts in a way that gives you the system at the end that functions. So this is straight from AS 15288, which is a systems engineering standard. And I put this up there just to, I guess, show that systems engineering does encompass a lot of activities. Importantly, you might notice that there's also the agreement processes at the front, because I think anybody that's working in systems engineering needs to understand the contractual environment that they're working within. And that can separate people that work just purely in a process sense, and those that are trying to effectively add value to the clients and that we work for. Sorry, that's a bit hard to read, but I'll move on. So one of the core components of systems engineering is the requirements management, leading to verification and validation of your requirements. The requirements actually originate from somewhere. This is a diagram that comes out of the ASA standard that was based on something we did on Parameter Light Rail, where the business requirement specification is actually the summation of your stakeholders' needs and agreed requirements. That includes things like what are you trying to achieve from the, by putting this project in place in terms of economic benefit. How do you plan to operate as a concept, incorporate those, and how do you plan to maintain it? So those sort of all roll into the business requirements, which you then roll your do the analysis required, do your definition designs, and then turn those into system requirements that are actually more concrete, verifiable, and can be delivered. We do a lot of work in the design and construct space, and this is the process that we run through on that we're actually running through on Western Sydney Airport for multiplex. And just in terms of broad brushes, the first part is about focusing on getting the right parties the requirements that they need to deliver against. So there's an allocation process, and also you work through your requirement set. What can you actually deliver against? What contradicts each other? And what are those non-compliances that you need to then agree with your client that you want to deliver against some other requirements? Then the focus is moving to designing those to meet those requirements and evidencing that the design captures those requirements. Which, if we've done the job properly, you get your system, it plays into your system safety. You also think about what controls you need to have in place there. You generate the requirements to ensure that you deliver them in the design and the construction phase. Once you've got your design, you move to the point where you've got approved for construction design. It's then about what are we, how do we map those requirements into our inspection test documentation so that our quality management system can deliver those requirements and evidence that we've actually delivered what we said we would. So some do's and don'ts for requirements management, and I've tried to pick up an assortment from ones that you consider from the client side through to the delivery side. So when you're on the client side and you're writing these requirement specifications for for the contractors to deliver, capture the key decisions that you've actually optioneered and analysed, but don't over specify. There's been numerous times where we've had to change requirements that were overspecified. You didn't need to say that because you haven't done the analysis. There's not that sort of item on the market, etc. And what it just leads to is lots of commercial discussions where you have to then have a contract variation. So don't overspecify. I think one of the key things is understanding when you're a client where are you best placed to make a decision? Where are you going to use your time to analyze and make the best decision? Is it a grade separation? Is it a level crossing? Is it a tunnel? You know, use requirements management for technical compliance rather than contract compliance. I may have been guilty in my past life as a client of going for contract compliance and causing a lot of work downstream that I didn't need to. I had the opportunity to audit said project that I specified and found that they were spending too much time on contract compliance and not enough focusing on the system that they need to deliver against. So you can dilute the benefit of the requirements management process. Use the right tools. So we work on TAP projects, which have in the order of 200 technical requirements, to Western Sydney Terminal, which has 26,000 requirements. Doors is a good tool for managing the 26,000, not necessary for managing the 200. So you don't need to apply one size fits all. Use appropriate tools. Allow time for the allocation and review, and I think that's a step that's missed in a lot of design programs. It can't be done instantly. It takes time to work through those requirements. I wouldn't use requirements management to replace design coordination. There's a temptation to, okay, the architect needs to add the switch there, the electrician needs to have that, and it's also a comms piece. So let's give them to all three. Give the requirement to one party and assume that design coordination will deliver the rest. Because that as well you can spend more time and money than you need to in delivering those requirements. In the delivery phase, mapping to the requirements to the ITPs to deliver, so that your quality management system can verify and validate those requirements. A bit about systems integration. Now, this is a diagram that we talk about where there's multiple levels of system integration, where if you've got a change portfolio, call it a new timetable, which leads to multiple programs of work. Those multiple programs need to come together to actually give you that change timetable. Those programs of work may have a couple of station upgrades associated with it, a couple of signaling projects. Those ultimately come together to meet your program, and so you have an integration level at your program. Those projects are then broken up into work packages. So I guess there's a layering of system integration which needs to be planned for and clearly articulated who's responsible for each level. On some of the projects we work through, they also talk about different levels of integration within those projects. So level 3 might be subsystem integration. Level 2 is those subsystems working together, and 3 is making sure that the overall operations with those combined subsystems work. There's also integration in the design and delivery phase. So in terms of design, one thing you have is you've got all your different designers working through their disciplines. There's emergent properties that come out of those disciplines, whether it be a noise impact, EMC, electrolysis issues. In stations, you have fire and life safety, and you can create vulnerabilities in your security at the interface of all of those packages. So interface management is the pulling together of those. Hey, electrical connector needs to go to the signaling system. How much power do you need, etc. So managing those interfaces. But then there's emergent properties that you need to manage in the design phase that should inform your design and create requirements. Once you've got that integrated design piece, then you can go to the delivery of that. So you're delivering your subcontractors delivering your various pieces of work, which ultimately gets integrated when you run your site acceptance testing and your testing with your operator.
Jonathan, what's N and B? If after NSC?
Noise and vibration.
Oh.
So yeah. If you've worked on a rolling stock project, noise and vibration is a killer. So do's and don'ts. Clearly identify your system integration responsibilities in your contracts. Leaving it vague leads to disaster. Actively manage those transverse disciplines. manage the integration early, so plan it out and get those plans in place. And when you have a complex project, such as a digital systems, having that common understanding of the system architecture is actually really important to align people's scope and understanding. Configuration management. Now, configuration management in transport. Sorry, when you look up the words configuration management, what's the definition of it? It sometimes comes back with managing the configuration. What exactly does that mean? I'll thank Richard Skoda for giving me this cartoon, which I think explains configuration management in a very succinct way. Now apply that to a railway, right? We've got the City Trains network that's out there now. It works, it's safe, it does its function. The people that are managing the configuration of the network need to change it. If there's a proposed change, you need to understand from this steady state configuration to the next, what's the delta and what is the assurance that you can provide me that says it's safe, it's going to meet its functionality requirements, that it's going to be reliable, and that the operator maintainer knows what to do when they receive it. So that is effectively why configuration management is tied to assurance. We don't want to swap people's lunch bags with parachutes. With any configuration management process, and a lot of people in the room will be familiar with the various gates that an organization like Transport has, approval to construct, approval to test it, and approval to hand it over. One of the experiences we've had is that there's an art to going to the gate and getting approval. You don't want to go with no assurance information to get that approval because you're too early, you can't make a robust assurance case. But you can't wait till you have complete information either. The reality of the world is that you want to be building and then you want to be giving it over. You don't want to wait this 8-week period for you to get the documentation together and hand it over. So it's about getting to the point where you've got satisfactory assurance information and you can explain the gaps that you have in that and the risks of that presents and your plan for closing it out. And that puts the people improving the giving configuration change approval in a position to approve in time to deliver your project. So do's and don'ts. Consider that you apply configuration management not just to the assets, but to the operations and the processes. If you are delivering a complex project, you want to have a configuration map, which allows you to lay out how you are planning to assure the client. Consulting the approving party is always a good idea, so you don't get surprised when you come to actually obtain that approval. Package those submissions appropriately so that you're going with a reasonable amount of information, not here's our toilet submission, here's our park bench submission. And clearly articulate the gaps and risks with the plan to close them out. Don't hide the gaps. The idea of through assurance is that it's a transparent process and that you are faithfully reporting what you have. That's it really. Any questions for Andy, Dave, or myself?
Can I ask a question?
Sure.
Just the boundary between making the design safe and constructability and making sure that the construction process is safe. This can be a very different question. I know you guys have considered to be quite strong in this area. You give me like a couple of minutes on how you do that and approach it, particularly for bridges, which can be very challenging.
There's a great example, and when my time in Network Rail in the UK, it's called Hoopath Bridge, I think it is. It wasn't a particularly good name for a bridge, but there was an incident around it that led to chair being introduced to Network Rail. So the designer who designed the bridge, sorry, I'll come over here. The designer had designed the bridge. It was all fit to go into the gap. It was taken to site. It was lifted, and as it was being lifted, all the lifting slipped, and the bridge landed on someone's hand, and they lost all their fingers.
So safety and design and the chair process is when you've actually got your initial design, is then looking how you can design it so that it can be constructed safely. So that bridge could have had lifting points built into it when it was designed, such that when they went to take it onto site, they clipped into the lifting points and it was lifted and put in without any movement. So you do your initial design process. As you're about to go to construction, you then have a look at how we can actually construct it properly. And that depends on your construction staging, your construction planning and those kind of things. So it comes at the ladder end, and that's when you actually have the constructability approach. You get the people who've worked on site, how are we actually going to put it together? The designer often designs something and then the builder comes and says, I'm not going to put it together that way. That's ridiculous. I'm going to put it together this way. And it's important that if they change the construction intent, that they go back and make sure that the design is also brought up to speed, so that when they're lifting that bridge beam, it's done in a way that is safe.
So you put it through that normal hazard process. You don't do it's something else.
You tend to do a chair workshop is one of the terms that is used quite often. So when you've got your design well advanced, you then go through a very similar process, but using different people. You get your construction people on site, you get your site health and safety people in who've got more understanding of actually the construction process itself, rather than the bridge for the next 100 years once it's been built.
Just when you were showing all the elements of the process, as a surveyor, I see a lot of flaws at the beginning of projects in identifying spatial integrity of the land plan to work with. Several projects I've seen come unstuck in the early stages because the cadastral layout is 2D under old systems. And then you're running a three-dimensional terrain model. Sometimes there's not good compatibility, and that's the very start of the project, because that's going to affect where all your mechanical pipe work, all your systems, all your underground systems eventually can be put. And if they suddenly find that, all of a sudden you're actually encroached on somebody else's land, that has happened. So that's just something that's just an element from my perspective to say that identifying spatial integrity is really, really important, because that can really blow a project apart.
We're supporting the central Western Gateway development right now, the big Atlassian tower that's going up where the YHA is, and actually trying to understand the different layers of the land boundaries as when you come out to Devonshire Street Tunnel. Oh my good God. How that's been put together, and anyone has kept track of who owns what, where and when, I don't know how that's evolved over the years, but there's so much time and effort going into millimetre ownership and easements and property and permissions around that. I completely agree. Spending the time up front and planning that, and it's not something I've come from. I'm not a civil, but I completely get now exactly why the time and effort has to go into it.
There is a question from one of the viewers at home. The question is, in ArchArtifex opinion, should the client invest in developing comprehensive systems and technical requirements, or defer that process to the suppliers?
I think, yeah, so I think there should be some level of development from the government where they're best placed to do so. For instance, the Sydney Metro lines now. Sydney Metro could possibly have standards that are network standards, but when it comes to the actual technology that's used on each line, they may be independent. So at that point, you go and get input from your suppliers when they get awarded the job, because they'll have different technology platforms and so on. But once they're locked in, then that becomes line standards, for instance. So you want to be able to obtain the benefits of interoperability where you need. You want to have consistent look and feel where you need for a Sydney Metro, because it's the same passengers that encounter the various lines that will be in place for the 3 lines that are planned. But the technology standards can be different because they're distinct lines and they don't necessarily need to be interoperable. So does that answer the question of said person?
We'll have to assume so.
I can add a bit more.
Yeah, go.
Yeah, look. So I'll add a little bit more to it, and it's more, I think it's probably a frustration I find. I've spent I'd say more of my career in the construction phase, less so in the design phase, more in that construction, delivery, commissioning, closeout phases. And thinking back to when I'm getting a client spec, I've got a suite of requirements that I'm trying to meet. I'm reading through those requirements and I'm thinking, how on earth am I going to answer that? And trying to work out, you know, you're reading, so you get this spec that's been written right back at the client phase, and it's so broad and wide sweeping statement. You're trying to work out how on earth you're going to answer it. You know, just plugging stuff in that's not adding value. And so there's merit in having the suppliers on that journey to help identify what those requirements need to be, so that when you read it, you go, yep, I know I've got to provide for that. I know exactly what I need to provide for that at the end of the day, or the end of the project, to actually really add value in defining what that project looks like.
But I think I'd just like to add a little one, because you mentioned earlier on about the contractual context of where we operate. I think that's got a big influence on the level of development that an organisation has to do. The second you make a cut in your project along a delivery line, then that pulls in a whole bunch of additional work we have to do to define that cut, and then to define that interface between them, and then how you integrate it across the developments created. So I think it's a good question that's very difficult to answer without a lot of different information, like how are you going to deliver the project, how are you going to drop it up, what's going to be fees, what's going to be constructability detailed and something.
I'll go forth on that one then. We'll do that. So again, I worked for transport for a while, and it's a constant battle between designing a product and then handing it over to someone and say design a product, but you've actually already designed it. There's a brand new train running around. I won't say which one of them. And the scope of work and technical criteria that went to the client was a full train design. They basically had to just build what they were told, but then they had the risk. They had the designer risk, and said, it's your risk for building what we've given you then. The flip side, when you put business requirements out, some people come back and you know, everyone knows Mr. Spiteri, who used to go pull his hair out about this. That's not what we wanted. Why have you designed that? Because you specified this outcome, but you didn't specify why you specified that outcome. So when you hit a requirement, you have to say why you've specified that requirement. So when it's interpreted in the intent that you want, not in the intent that somebody else sitting in a design office who's never been out to track things as well. So getting the balance right between specifying what you want to achieve without specifying the means by which it will be achieved is the tricky balance. And I've not really seen anyone get it right in government that I've worked with.
So I will just add one more thing to that. And I look at people like David in the audience, and the reality is there is also a time constraint. In the perfect world, you might go, okay, I want my contractor to come in and select that. But ultimately, there's only so much time in a tender phase. So sometimes I'd imagine you're quite happy that you've selected a product. Okay, sweet. Don't need to worry about that. I'll focus on the other areas that I can add value to and innovate. Would that be correct, Dave? Thank you.
Yep, sure.
Look at your presentation, especially the safety assurance. At least go to executive team. Actually, still something to this city. Being those that are labeled, who actually aren't executive, not necessarily. I don't have a professional operation to handle that. I think you really tell this.
Yeah, no,
understanding. You don't have to dig into everything, but you can have a level of trust.
Yeah, it's a good point, Rob. I know there's so many projects happening at the moment, and this work can quite seem consuming. We refer to it as a paper project, so it's as big as the actual project itself once you compile all this documentation. I might ask to hear your view on how you think it is best managed on a big project. I know it's a broad question, so maybe just a summary on how you see this unfolding in the future to make it more efficient, because it sounds like there's still room for improvement.
think from a system safety perspective, as I said, quite as a bit of a joke at the start, most system safety people are Northern British males. There's an entire new generation now of people who are doing that role. You know, one of our graduates is in today, and it's making sure that the knowledge and experience and decision making is passed on to those people so that they know when to say yes and when to say no. It's very easy to take the ASA standards off the shelf and comply with them. It's expensive, it's time consuming, but it's the easiest thing in the world just to follow that big list of requirements. For someone to say, you don't need to do that one, you don't need to do that one, you don't need to do that one, just do this bit, and you'll actually get the same outcome. That's the key for me, is passing on that knowledge of when to say no, stop doing something. And that's, again, what we're trying to do.
Brilliant. Okay. Is there any more questions from the audience? Actually, there's a few more from the audience at home. So I'll just check. Okay, so another question is, Cisa is perceived as another dark art, and often suppliers fumble along until there is pressure to deliver the project to meet a deadline and the Cisa intentions are ignored. How do contracting firms allow appropriate cost provisions to address Cisa requirements demanded by the client?
Yeah, I'll leave that there for you. What's that last? A dark art. I like that. Look, I think Jonathan's. Think back to the do's and don'ts that both Andy and Jonathan had on there. You saw how that planning. You know, Andy talked through about the plan. Was it plan, do, check, act? Was that plan, act, check, do? Yep. Plan, critical part to it. Jonathan also talked around, you know, the amount of time and effort that we put in up front to actually setting up the interfaces, understanding the interfaces, so that the work then, the system then fits together. It's engaging with organisations like us early, where if I'm real life example, I'm working on a brownfield project at the moment between Sydenham and Bankstown, hypothetically so. We've been, I was out there again today and had a quick change in the car park before walking in here. But I was out on site today, and a lot of the conversation was, okay, there's been a fair bit of change. You know, we've spent the last, since really January, where are we now, November, 10 months in actually setting things up, understanding those interfaces, understanding all the requirements, understanding how we're going to meet those requirements, understanding and looking at the risks and the hazards, and understanding how we're going to evidence those and close those out as we go through the project. And we spent that last 10 months doing that. And today was then going through again with the team to then remap how we're going to get to the end. You know, where we started that job by looking, okay, well, these are our portions. How are we going to actually show that we've met each of those portions when we need to hit that date a year and a half from now? And that's the part of the planning that we're doing up front to ensure that we're going to hit the milestones at the end. Does that answer his question?
I just add a bit of the black art thing. I think, you know, with the graduates that start with us, we talk about building your mental model. With Cisa, I don't think the principles are that hard. You just need to be able to attach them to things that you might call something else. So the classic case being the bridge is also a system. Okay, I get it now. I can connect all of that information that I know about bridges into the concept of a system, right? So I think it's just about not being afraid. And it's about opening your mind to build on your mental model. These are the assurance processes that run alongside the engineering processes.
Fantastic. Okay. That's great. I don't think there's any more questions. Okay, we'll take this as the final question from the audience at home. How do you measure the value of Cisa implementation? Railways have been delivered for centuries without safety engineering assurance.
As I said, in the UK, if you look at Clapham Junction, if you look at Ladbroke Grove, you look at Hadfield, you look at all of those things like Waterfall and Granville over here, they don't happen anymore very often. That's how you measure the value of safety assurance in the railways.
That's a very good point. Yep, safety is improving in that space, so good argument back, Andy.
in one sentence.
Okay, thanks. We'll close the session then. Finally, just thank you to the viewers at home and thank you to the members in the audience. Our next technical meeting is on the 17th of Feb and will be sponsored and presented by JMDR. Again, a big thank you to ArchArtifex for sponsoring the event tonight. I found that really insightful and knowledgeable. It's great to have people that can share the dark arts, as they call it, to people to enlighten the wider industry. So thanks a lot for your time and your presentation, and I'll see you next time.